This is a graph of x and y axis. I am going to explain what is eigenvector graphically. Okay, so this graph has got four quadrants. So first, second, third, and fourth. So origin is here, and it is like 1 comma 0. This is 0 comma 1. Okay, I will apply the transformation. After applying the transformation, if this 1 comma 0, this is a vector, okay, it has got a direction. This is 0 1, it is another vector, it has got a direction. After applying the transformation, if this direction is same, like for example, if it is either multiplied by a factor or divided by a factor, let's say this value into 2 means this is after applying transformation it becomes 2 comma 0, means it's on the same line, correct? So this is eigenvector. After applying that, let's say if this if this rotates if this rotates means it will not lie on the same line, correct? It will go somewhere here or somewhere not on this line. Rotation means it could go in any direction, it could be here, bottom also, it could be top also. So in that case, if the transformation is rotation, it is not eigenvector. These are not eigenvectors. Okay. If the transformation is like scaling up, which means this 1 comma 0 will become 2 comma 0, 3 comma 0, something like this, or maybe minus 1 comma 0, minus 2 comma 0, then still those that is a eigenvector. If it is 0 comma 1, if it is 0 comma 2 3 4, or 0 comma minus 1 minus 2 minus 3 minus 4, if it becomes like this is also eigenvector. Instead, if 1 comma 0 becomes 1 comma 1, okay, the point is here, 0 comma 1 will become minus 1 comma 1, means that is not eigenvector. Wherever it is currently, it should go on the same line. Okay, need not be same direction, same line. 1 comma 0 is in x-axis, correct? So it should be anywhere on the x-axis that after applying the transformation, then it is eigenvector. 0 comma 1 is on y-axis, so after applying transformation it should be anywhere on the y-axis, means it is eigenvector. Let's say it's a diagonal, in the sense 1 comma 1 is there. After applying the transformation, if it becomes 2 comma 2 or 3 comma 3 or 4 comma 4, etc., it's an eigenvector. If it changes its angle with the axis, means it is not eigenvector. Okay, so let us see one example. I have already made calculation. Let me change the color, it will come. So I have my vector 1 comma 0 is this, okay, 0 comma 1 is this, and this is the transformation. Let me increase. This is the transformation matrix. Okay, so this is then let us apply the what to say let us apply the transformation. What does this mean? We just need to multiply this value, this matrix, with the vector av equal to lambda v. We studied as Eigen formula, correct? Transformation matrix is called A, and v is a vector. Okay, so I have done the calculation already. So this is my original matrix, and I am multiplying with 1 comma 0. I get if I multiply both, these are, I mean, these matrices are compatible, so it can be multiplied. So it becomes 3 comma 3. So my original matrix 1 comma 0 has been scaled up to 3 comma 3. If I take 3 out, it becomes 3 times my original matrix. Okay, this 3 could be any value, 3 or 4 or minus 5 or minus 1 or any value. If this initial matrix and final matrix are same, after taking the common factor out, this common factor is called eigenvalue, and this is called eigenvector. So far good. So I have the y-axis calculation. This is 0 comma 1. Okay, let me expand the font. Okay, so my transformation matrix is here. I multiply with 0 comma 1, I get 0 comma 3. Okay, this 3 times 0 1. So this initial matrix, the initial vector matrix, and this matrix final matrix both are same, means this is eigenvector and this 3 is eigenvalue. Okay, I have another example, so I have hidden this as well. Let me show, just a minute. This is another example. Okay, my transformation matrix is 1 2 0 1, and this is 1 comma 0. After applying the transformation, this 1 comma 0 becomes what? 1 plus 0 and 0 plus 0, correct? So this is 1 plus 0, 0 plus 0, this is 1 comma 0. So 1 comma 0 is same as 1 comma 0, the eigenvalue is 1. Okay, now this, for this matrix, for this transformation matrix, this is my 0 comma 1. Okay, so if I multiply it, it is 1 into 0 is 0, 0 plus 2 is 2, 0 plus 1 is 1. So this will become 2 comma 1, correct? So 0 comma 1 is y-axis, correct? This is 0 comma 1, it becomes 2 comma 1. So this my initial matrix, that is 0 comma 1, is not matching with my final matrix 2 comma 1. I cannot take any factor out and I cannot make it 0 comma 1. So 0 comma 1, for this transformation 0 comma 1 vector is not an eigenvector. That is the conclusion. Okay, and for the same transaction, my 1 comma 0 is an eigenvector. Here is the proof. After applying multiplication, I still get 1 comma 0, which means its eigenvalue is 1 only, and that is a scaled value is 1 only. Scaled value is called eigenvalue, and the final value is like 1 0 only. So in this video we saw two examples. We saw two examples. One is after applying the transformation, both the vectors became both the vectors are eigenvectors. Okay, eigenvalue is 3 for both of them. That is example 1. Example 2, after applying this transformation, I don't get the eigenvector for 0 comma 1. Okay, but I get eigenvector for 1 comma 0, which means eigenvalue is 1 for this vector. Eigenvalue is not defined for 0 comma 1. That is the meaning. Okay, this is 2 by 2 matrix, which is 2D. If it is 3D means imagine we have one more axis here. Let me expand further. Imagine we have one more axis here. Okay, so angle of axis of rotation is what matters. When we scale x, when we scale y, okay, so it becomes value and eigenvectors, no doubt, but the z axis x, if it is 3D, it will have z axis, right? Z axis is not is rotating on z axis, means z axis vector doesn't have eigenvector or is not eigenvector. That is the meaning. Okay. And similarly for multi-dimension, 4 dimension, 5 dimension matrix, uh, the same way, but it's a complex to visualize as well. Which instead of just for understanding purpose, I have made this video. What is eigenvector? Eigenvector is nothing but if it scales in the same line, any direction, opposite direction or same direction, doesn't matter. If it scales up or scales down on the same line, it means it's an eigenvector. How much is the scaling factor? That is called the eigenvalue. Alright. Thank you.